Welcome to this way. I'm going to explain how you can do inspection or how you should do inspection and perform inspection of pipes and prepare a report exactly meeting our requirement as well as expectation by the customer. Let's dive in. First of all, say you are doing inspection of a seamless pipe. So you need to know the seamless pipe manufacturing process and what kind of variables can come in the process that can affect the quality of the pipe produced. So our inspection starts from the very beginning, from billet stage. For example, seamless pipes are manufactured by piercing process. So the billets, round size solid birds kind of thing, billets are heated at a defined temperature, typically about 1200 degrees Celsius. The billets are heated in a rotary furnace, and the time is set in such a way by the time the billet comes on the exit point, piercing point where it starts, the billet attains the desired temperature. Now this is grabbed and put into the rollers, and where the piercing equipment goes and pierces the whole solid and makes a mother hollow. And then there's a straight end. These are sizes are controlled, thicknesses are controlled by the machine. And then finally, it comes to the bay, typically around 600 plus 650 degrees Celsius, close to 700 degree. From there, they get cooled in the bay. And that process simulates normalizing process. You know, normalizing is a process where you heat the steel into 650 to 620 to 650 degrees Celsius, hold it for a certain duration, and allow it to cool in normal temperature. That's how it came normalizing. So the speed of cooling is more rapid because this is exposed to the ambient air and ambient temperature. Now the same thing, if the cooling is done in a furnace in a more controlled manner, for example, 300 degrees centigrade per hour is the cooling rate, then, and the cooling happens in a furnace, you will call it annealing process. But normally the seamless pipes are normalized by the system design itself. After the piercing, mother hollow is straightened, the bare pipe is manufactured, and then it gets cooled down. Then normalizing process is completed. So desired property, which includes basically the right tensile property. So these are the three things will be controlled by this process. Depending on the customer's requirements and the specification, some pipe may be subjected to a different heat treatment. For example, quenching and tempering. In this process, the pipes are very rapidly cooled by sprinkling of water jet. By doing so, the hardness is increased. The hardness is naturally increased when there's a very rapid cooling and the martensite is formed, which is very brittle and hard. Now, to restore some amount of ductility and balance the property, those pipes are subjected to tempering when they are heated below the transformation range, and then right amount of hardness and tensile property is achieved. And then ends are cropped because all the defects will flow and the edge will become irregular. So some amount of pipes ends are cropped from the ends, and that is discarded and going back to the recycling process or going back to the furnace again for remelting and to form the fresh pellets. Now, from there, NDT starts. The pipes are now cooled. Now, this will go through NDT process. It could be eddy current testing, ultrasonic testing online, and there is no seam, so no X-ray. Question of X-ray is coming. So then, after that, you test the ends because the extreme two ends may not be possible. It may not be possible to do UT on the extreme end. So ends are where the welding will come, beveling will take place. So, and that is where you need to do inspection thoroughly inside and outside. So MPI, typically fluorescent method is applied to inspect the bevel edges, that there is no fine crack or any cracks or the defects that has flown toward the ends at the time of piercing and forming process is cropped and the pipes are free from such manufacturing defects. Ends are also ultrasonically tested because the automatic machine may not be able to test the ends. Therefore, the ends are manually tested. Once this is done, the pipe goes for hydro test. Once this is done, the pipes go for hydro test. Now, hydro test is performed at a pressure which is calculated by a formula PD by 2T is the stress. So if you consider 90% of SMYS, and that is the stress you are considering, and then PD diameter and 2T the thickness. Once you do that, you know what is the pressure from that formula, and that's the pressure you are actually testing the pipes. Mind it, you are doing at 90% of SMYS, so therefore you are not reaching the point where there can be permanent deformation of the pipes during hydro test, and that's very important point. You do not overpressure, but test it for sufficient long, 7 seconds, 5 seconds, 7 seconds are specified by most of the standard, but certain standards or client might need more, for example, 10 seconds. So whatever is the duration required and specified in the purchase order, you have to do at that pressure at that for that duration. And once this is done, there is no visible leakage. There is no deformity and defects on leakage. There is no defect or visible defect. There is no leakage. Then the pipe is considered passed. After this, beveling will be done because the pipes will be finally welded. Normally 4-inch, 6-inch, and 2-inch pipes are also beveled because they are welded at site. So you need to prepare the groove, and that's where bevel and preparation will be done, which is normally at 30-degree and with 2 mm root face so that you can create um, a single V joint, and that's where the welding will be done at the site. So these are, and then of course after that you are doing some kind of protection for the material body. So some lacquer coating is given for prevention from corrosion or superficial corrosion even while they're transported and they're stored. So a lacquer coat is given to prevent surface corrosion, and sometimes the pipes are shipped in the corrosive environment, so they are protected. Ends are protected with end protection caps to protect the bevel and as well as the root face. Otherwise, you need to do whole thing once again at the time of welding, and that's a huge impact on productivity. And once this is done, the pipes are marked. There are API guideline on what has to be present in the marking. For example, the size, schedule, and then the API monogram license, the condition, bevel ends, heat treatment, heat number, batch numbers, etc., whatever is required. You have to look at what are the requirements for the marking, and exactly the same marking will be applied on that. And that is the monogram license, a requirement by API as to how the marking will be applied, and monogram, API monogram will be applied on the pipe. Who is responsible to do that? It has to be done by approved and authorized person because you are using API monogram. The pipe has to meet all the requirements of API specification, which is 5L, different grades can come grade B, grade 40, grade 46, grade 52, grade 60, whatever grades they are, all those grades will be marked on the pipe and the ends are protected. Number of pipes are strapped together that you can handle and then they are shipped. And of course, there will be a packing list of what is going out, what is the batch number, and that is when, before the marking, what is tested, what is verified, the material is tested and satisfactorily. All hydro tests and other tests are performed, all NDT is performed, all tests are done to the satisfaction of the verification personnel and the specification. And once this is done, the pipes are marked. Once the pipes are marked and strapped and protection caps are provided, they're ready for shipment. And that's where our job ends. Sometimes it involves pre-shipment inspection, checking before the shipping happens, and sometimes even loading of the pipes in the cargo hold that is also done based on the requirements. All these stages and verifications are included in a document called MPS, Manufacturing Procedure Specification. So, as an inspection engineer, you must look at the approved manufacturing specification, MPS. You have to apply ISO 9000 requirement here. This is a document of external origin to your company. So this is what, as an inspection service provider, you are going to refer. So look at whether this is the latest revision of the manufacturing specification that you are supposed to verify. For example, in one manufacturing specification, latest revision, the duration of test, hydro test has been increased to 10 seconds from 7-second standard or 5-second standards. So you need to witness the test and ensure the test is performed for 10 seconds duration. Pressure is given for hydro test in the manufacturing specification. It may be possible that heat treatment, additional heat treatment is specified. You may have to check whatever are the requirements. They are all fulfilled. For example, calibration. Sometimes standard calibration can be done at 12.5% of the thickness. Customer, based on their application, can opt for 5% of the thickness, which is more precise and more stringent requirements. So any defect within the 5% of the wall thickness will be detected, and that's the level of calibration you have to do. So these are the requirements which might be part of the manufacturing specification MPS. So you need to look at the MPS before you do the inspection. At what frequency you are doing inspection, what all inspections you are going to do, to what extent you are going to sample. This will come from a document called Inspection and Test Plan. So I will show you now how we do inspection with some amount of documentation. So this is how we are keeping record of each items that we are inspecting, each order. We create a folder called assignment. Each assignment is numbered for traceability. So we can trace, okay, this is the customer order number that was placed on us. For that, we have created an assignment. So all inspection will be traced through that assignment number. All correspondence happens through that assignment number. So if we are to find where is this report coming from in our email, we'll just type the assignment number. All reports for that will appear. So for example, let me take an order, so HVST, Angyong Valin Steel Tube. It's a company in China. 686 is the assignment number. Okay. So this is our assignment number 697. So this has come from the customer against a contract that we have, and we need to know the purchase order requirement that the customer placed on the supplier, because we are going to ensure all those requirements specified by the customers are complied with, are fulfilled. So we have to see what is the purchase order. So in this purchase order, we are saying this is a supply of pipe agreement, pipe supply agreement. It is between Mechanical Engineering and Contracting Company and Hangyong Valley Steel Tube Company. There's a company in Hunan province in China. Second party obligation, all those requirements have been specified for submission of documents, packing and shipment, laboratory test, and nature of work. All those things are part of the standard purchase order. And we look at all, even the language, all the documents and records will be in English language. All these are part of contract between the manufacturer and the buyer. And we have to ensure these requirements are complied with, and they are also specifying that they will engage a third party inspection company on their behalf, and the third party inspection company has to be provided all reasonable access to ensure all the required inspection and tests can be witnessed or verified by them to ensure conformity on behalf of the customer. Now, see, this is the material. So it is 8-inch pipe, schedule 80, and X60 is the grade. And this is carbon steel seamless pipe, bare bevel and 12-meter random length, double random length, API 5L. The grade is 60, grade 60, PSL2, product specification level. This is a level as defined in API 5L standard. PSL1, PSL2 will correspond to certain mandatory inspection and requirements suitable for sour service. Sour service means it is H2S service, compliance to NACE MR 0175. So these are some of the things you have to verify. In line with contract requirement, the latest edition of the 3-layer extruded high density polyethylene system, HDPE coating will be there on that, which will be additional requirement of all the pipes will be coated with 3-layer PE coating. And that is the specification UCP 004 part 6 revision 4. This is the specification given by the buyer MSSC on the supplier or producer, which is Hangyong, to make sure these requirements are complied with. And these are the total requirement. Total quantity is 1,939 metric ton. And that's the number of pipes and quantity. So we have to make sure that these are the items produced in accordance with the requirement and in during the manufacturing at a defined stage we verify. Now, what are the defined stages? The defined stages are coming from ITP. Now, as I mentioned a little while ago, there is a manufacturing procedure specification. A document is prepared like this. So, manufacturing procedure specification of line pipe. This is a document approved already by the customer, and there'll be a revision number. So we'll have to make sure that the manufacturing happens is in accordance with these revision, and latest revision is followed, which we take from our customer, and the contract number is this against which the item will be manufactured. This contract number is contract between the buyer and the manufacturer. So now these are the kind of revision happens, and the whole process of manufacturing is included here. I have mentioned briefly it goes to electric arc furnace, then ladle furnace, the continuous casting machine for the billet manufacturing, inspection and check of billets are done. This is for the billet, and heating of billet happens, and then pipe are piercing process, and the hot rolling is done, then sizing, air cooling, that's what I talked about, normalizing, and then saw cutting, edge will be cut, and then quenching. They are cold, the temperature. Quenching is when the pipes are cooled in water bath. So water quenching is done for more rapid cooling. And then these pipes are also tempered, so they'll be reheated to certain temperature. So there will be a procedure for tempering. There will be procedure for quenching. At what temperature the pipe will be introduced in the water for sudden cooling, and then hardness will grow very rapidly because quenching increases the hardness, and we have to meet the hardness requirement also, because for higher grade you need some amount of hardness as well. So there is a specified level. You cannot go beyond that hardness that is specified either in Rockwell or Brinell hardness, whatever is the specification. Then the pipes are tempered, and then MPQT, manufacturing procedure, has to be qualified. And these are some of the major requirements of carbon, manganese, sulfur, silicon, phosphorus, vanadium, niobium, titanium, copper. These are some of the elements given, nickel, chrome, moly, all those items that is specified here. There will be a maximum and minimum limit. For carbon, it is normally maximum. Carbon, manganese, silicon, these are all maximum level specified. And then there'll be a carbon equivalent. You have to calculate carbon equivalent, which is calculated using this formula called C plus Mn by 6 plus chromium, moly, and vanadium by 5 plus copper and nickel divided by 15. And there is this maximum specified limit given for carbon equivalent. And once everything falls in this range, a carbon equivalent also should fall within the acceptable range. But we'll have to verify that, and this is reported in the MTC. So once this is done, then mechanical testing will be done for tensile, for yield point, for elongation, for reduction, percentage reduction in area, and then of course the hardness will be done. Sometimes Charpy impact test is done. When Charpy impact test is done, because it's higher thickness, it is quite possible to get full thickness. So full thickness is 10 by 10 and 55 length with a V notch, which is 2 millimeter deep. And minimum value required is 27 joules. And the test temperature is also will be specified in the specification at minus 13 degrees centigrade. Charpy impact test always comes with a temperature at which the Charpy has to be done and the minimum required value, and one individual sample value can fall, but this cannot be below 21 joules. That's the most of the requirement. So once you are looking at Charpy impact test, the most important thing is the dimension. So we normally check this V groove 2 millimeter deep in a shadow graph, because the root there has to be a right curvature. Otherwise, it will crack at a much lower impact value. And that radius is very, very important. Will define the accuracy of the results of Charpy test. Charpy impact test. So once you do this test, it will be at minus 13 degrees centigrade. The samples, normally these are 3 samples, are tested together, and you take an average. And one value can fall, but cannot fall below 21, and 27 should be minimum average. And that's how Charpy tests are performed. And then hardness test is done. Grain size detection is performed. Normally this is fine grain, so normally 6 or finer. Coarse grain is above that. So if it is 5 or 6, this means it is finer. And then HIC test is done, hydrogen induced crack, and sulfide stress cracking SSC tests. These 2 tests are also done for this. And then NDT, of course, will be done at the time of online. We have mentioned about it. Manual inspection, visual inspection will be done for the dimension, for the thickness, for surface conditions, and hydro test we mentioned, and the finished ends of the pipes, marking and shipping. And just for rust preventive quotes are given. And then MRB is the final documentation package. That's how the whole process that I've already explained to you, this document is prepared and approved. So we'll have to follow, while we are performing the inspection, these kind of a manufacturing procedure. And at what extent we are going to check will come from the document called ITP, Inspection and Test Plan. Now, this inspection and test plan is again a documented information which is approved by the customer, because customer might need certain extent of checks. Every customer has got their own requirement. There may be more stringent requirement or less stringent requirement for the frequency, depending on the credibility of the manufacturer. So the buyer can consider, well, this is a very good supplier and they're very credible. They have got all sort of licenses and we have done business with them for long. So 10% random sample for all these items, maybe hydro test 10% is good enough, or dimensional visual inspection for 10% is good enough. But the same manufacturer might have gone through more rigorous inspection when they were doing in the beginning, first order, second order, third order, because the buyer still does not have the confidence that how good they would be to meet the requirement. And it will be a disaster if some faulty material arrives all the way from a distant location and shipped after a month of manufacturing and then month of shipment, and that will disrupt the whole project. So inspection is a risk reduction process. Everyone looks at the risk into their operation. ISO 9001 standard requires an organization to consider risk. So for a project, a faulty material arriving at a delayed, also delayed faulty material for a project company, faulty material arriving is a risk. Faulty material coming delayed is a greater risk. It is delayed and also faulty. You have to start the whole process once again, which will disrupt the whole project, and there'll be liquidated damage and the wastage of manpower and colossal wastage. The company might go into loss just because the pipes were delayed. So there's a huge amount of risk while procuring the materials to ensure the client wants to ensure that everything is done in accordance with their needs and expectation and the specification, and that's the job of a third party. So we act as the eyes and ears of our buyer and to make sure all the requirements of the customers are really fulfilled. Now let us look at an ITP, how it looks like. So X60, the grade 168.3 mm into 14.27 thickness. You remember the Charpy test I mentioned, it will be full size 10 by 10 by 55. So we can machine from the thickness 10 millimeter specimen, full size specimen, and then that's the requirement. And then what you are going to order review, we review the order, and we normally do a pre-inspection meeting before the production start. Vendor pre-inspection meeting is conducted to make sure the client is convinced that the supplier, the manufacturer has got a complete understanding, and they've got the machinery and equipment and the time slot, everything is ready, and they can assign their nominated third party or their own persons for verifying that everything is done right. Pre-production and inspection meeting is normally hold point. Hold point means where the client or the inspectors or their nominated inspector will have to be present. Hold point means you cannot move beyond this point unless this stage is completed. So the reviewing the document will be done, review MPQT, we mentioned that manufacturing procedure has to be qualified by test. So you normally make 3 or 4 or 5 pipes in the beginning and then perform all the tests, make sure all the requirements for chemical compositions, for mechanical properties, for physical requirements, for the dimensional requirements, for impurities or defect size, if anything is there, or flaws, or indications. I would rather say indications, if they are present, are within acceptable limit. There may be some indication, there may be a small scratch, but within 5% thickness. So that's an indication, but that's not a defect. A defect is an indication which is not acceptable as per the specification level, as per the acceptance criteria, acceptance requirement. For example, 1 millimeter is a scratch of a 12 mm pipe, 12 mm thick pipe. So it does not meet the requirement. If it is 5%, wall thickness has to be calibrated. So Depending on the specification level, depending on the accuracy you need to have based on the customer, you have to ensure the calibration is done like that. So then still making process, these are all part of intervention. Some of the things are reviewed, some of the things are hold, some of the things are witnessed. For example, hot rolling is reviewed. So we normally check or monitoring. Some places we can say monitoring because we have to check the temperature is right by random site visits. We monitor sizing operation is reviewed, saw cutting is reviewed. We don't have to really be present there because we are checking in the final stage many other important points. Now here quenching is also reviewed. Product chemical analysis is 10% witness. So when they are doing inspection, when they are doing chemical analysis of the pipes, 10% of the sample we have to check, and they are doing in normal spectroanalyzer, so will be present at the time of inspection. Tensile test 10%. The impact test, sharp impact test 10% of the samples. Hardness test 10%, and something like that. And grain size detection 10%. So like that, you'll find hydro test. The weldability test is done. HIC test is done 10%. SSC test results are reviewed. Straightening is basically review. And then if you look at pipe body NDT is 10% witnessed. Pipe end NDT, as I mentioned, ends may not be possible to cover by the automated machines, so manually these are done. And full body MPI. Full body MPI is done by blasting the whole pipe. The full pipe is NDT tested to make sure that there is no defect, and that is done. Here you'll find the frequencies given and the requirements. NDT report will be done, and this is a part of welding procedure. So shift change every shift and calibration for each hour. This is how it is pipe and NDTs are done. Full body MPI. A full body MPI, one pipe will be tested per lot or per 50 pipes. So if you are making 50 pipes, you take one pipe, do a complete blasting, and a full body MPI is conducted, magnetic particle inspection, typically fluorescent method, any crack or anything. Now, you don't know which pipe is going to come, and the 50, one of the 50th pipe, if it is randomly tested, it gives sufficient confidence that rest of the pipes are going to be okay because they're coming from the same series of billets, same manufacturing process, same heat treatment, same controls all throughout the process. So these are giving sufficient confidence based on random sampling because they are from the same heat or lot. That's the reason lot is important. If lot changes, there may be variation. So if there are more than one lot, so two or three lots, for every lot you have to take because the variation, these are one of the variable lot because each lot may have some difference in the chemical composition, so and the mechanical properties will be impacted based on the heat treatment, subsequent heat treatment during the manufacturing process. So you need to really look at this. And then you look at residual magnetism because um, all entities have magnetic fields will be created, magnetic flux inspection will be done, and magnetic particle tests are done at the end. So you have to demagnetize, otherwise at the time of welding, the electrode will be deflected. So you cannot do proper welding. There'll be defects produced just because the the magnetic field is pushing the electrode away, so you cannot hold it on to the root, and then weld defects will be produced, root penetration will not come, things like that. So dimensional visual inspection and hydrostatic testing. So you'll find this is a QC project. So QC specified pressure, you calculate the pressure and 10 seconds duration, and test report will have to be prepared, and we will witness 10% of that. And then beveling is monitored, and then measuring length and the thickness, etc. Marking, we check first off, we are checking, and after that this will continue. Painting, we are monitoring. It's not painting really, it's like basically lacquer protection for surface protection during transshipment. etc. Packaging, which will include strapping and end protection and stocking, those things are just reviewed. So this is how ITP we are following. And as we move, when we are completing those phases, typically here reviewed will say it's reviewed. For example, hydro test was done. For example, here I have got pipe and inspection release note. Release note is a hold. So release note means we have reviewed all MRBs, manufacturing record book. We have witnessed all the tests in accordance with this ITP, and we are satisfied that to the best of our judgment, these material has been produced in accordance with the manufacturing specifications. We'll give the reference. And we have inspected these items in accordance with this ITP revision, so and so. And we are satisfied. And that's what we are going to give in the release note. And for every inspection, when you're performing, we'll produce an inspection report. We call it inspection and survey report. And that report goes to the customer that this was the requirement and this is what we have exactly done. And once this is done, we will issue a release note. Once items are released, we are releasing the item on behalf of the customer, and this goes to the manufacturer. And manufacturer can use it and ship the material. And this sometimes is a condition of LC, which is called letter of credit, which is an instrument given to safeguard the interest of both the parties. For example, when the buyer is buying the material, what is the guarantee that the manufacturer will provide this material on time, meeting all requirements of the buyer? So once the release note is issued, that gives a declaration that they have complied with. So one requirement of letter of credit, which is held by the bank, who will actually release the fund to the supplier once they provide this document to show that, yes, this was our customer requirement, that the TPI-TCB is the third-party inspection company for them, and they have inspected the item throughout the manufacturing process, and they have reviewed the document and given us the release. So this item meets the buyer's requirement. So once this is given, then the supplier will get their money. Now, the supplier also wants guarantee. Okay, we have produced the material. What is the guarantee? That the buyer will pay us. And they have already incurred costs. They have manufactured and everything is now ready. They have shipped. Though the customer is not paying them, what is the guarantee that the customer will pay them? So that's where the LC will safeguard the supplier's interest also, because the buyer will open an LC on a bank, and they may have, for example, somebody is buying from Kuwait, so they will open an LC on a local bank. They will have a correspondent bank, for example, Bank of China. So, and Bank of China is holding that money in partnership, in collaboration with the Bank of, say, National Bank of Kuwait, NBK. And then once the items are cleared, Bank of China will release the fund to Hangyong Valent Steel Tube Company in this particular case. So this LC protects the interest of both the buyer and the supplier. The moment the money is held by Bank of China, which is guaranteed by for National Bank of Kuwait, there is no way that LC can be revoked. So it is called irrevocable LC. Irrevocable letter of credit. So this irrevocable letter of credit normally includes condition of delivery, whether there will be free on board or Ex Works or CIF, in meaning the material will come here and the entire cost of insurance and shipment, everything is covered by the supplier. So depending on that condition, the supplier will also have their understanding of what they are supposed to do, what is their contractual obligations, whether the shipment is on their side or not. They will be packed in brick bulk or they'll be put in a container or whatever the condition of the buyer will have to be fulfilled. There's another document called Bill of Lading. Bill of Lading is signed by the ship's captain. So this means the material were cleared by the third party or the buyer's representative or the buyer themselves. And now these material, this quantity has been loaded onto the ship. So this means the manufacturer has complied with their full obligations. They produced it right, full quantity, and loaded onto the ship, and they're also insured. So now it depends on the shipping process or the subsequent process. That is how the whole order is executed. Now I will show you a report, typical report, how we are producing a report on the vendor pre-inspection meeting when we do the inspection for the first time, and when we are doing inspection on a continuous basis, and what we do when the items are fully completed and met all the requirements of the standard. Let me show you a typical VPIM report and typical inspection report, as well as a typical release note. Let me give a very important disclaimer here. I'm very thankful to our client MECC for placing orders on us, and we are using a document of a Hangyang Welland Steel Tube manufacturing company from China. This document is purely for educational purposes. There is no intention for any promotion or anything of that sort. I've just used this document for educational purposes only, without any commercial interest attached with any parties involved. Now let me show the inspection report for a completed project that we have done. For example, an assignment 690. This job is completed. There was a pre-inspection meeting conducted. I mentioned about the vendor pre-inspection meeting. That's done to make sure that there is no ambiguity of the requirement. Customer is confident that the manufacturer has got a clear understanding of the requirement, and they've got all the processes. All documents are approved. Now they are really ready. In case of any deviation, that's the time they should clarify, and they will say there is no deviation. So we fully agree with the requirement. So let me show you a vendor pre-inspection meeting report. Typically, this is the format we use. You'll find all the details of inspections are included here. Objectives, equipment material used, review of a service contract, requirement, exception or deviation, and they say they have no deviation. Here they are saying they have got HOS test confirmed, have confirmed full understanding of the purchase order and all the attachment and technical requirement. And there is no exception or deviation have been proposed by the vendor. So they fully agree with all the requirements of the customer. This is how a vendor pre-inspection meeting reports are done. So we have included all the documents, what is the latest revision that they are going to use, and also vendor's quality assurance manual, inspection and test plan. Everything is reported in that manufacturing schedule, when they will start, when they will end, traceability, how they will maintain traceability. PSL2 specifies the requirement for traceability on the finished pipe right from the billet stage. In every stage, all inspection report has to be traced. That's how all these things are specified, and who should be the person involved from the client side, who should be the person from TCB side. For example, on our side, Nico Meng is our inspector, and this is how all informations are documented in the vendor pre-inspection meeting report. Once this is done, then you will have reports of inspection. So this is how inspection reports are coming. This is ISR 1. In ISR 1, whatever inspection they have done, they have documented in the summary. Here is what I would like to explain, how our inspector are actually reporting their observation. So this is the manufacturer, our customer name comes here, the location and the port where the inspections are done is in China. All right. And this is the manufacturer, and there is no sub-manufacturer. The manufacturer order number on the manufacturer placed by the buyer is reflected here. And where the inspection will be done, that's very important, because the manufacturing facilities must also be approved by the customer. So manufacturing has to happen in the approved location. Why? Because all the machinery, equipment, the processes have been checked and verified. The process capability has been established. If it is going to a different location, the machine may behave differently, and because of that, the quality of the product may be different. So each facility has to be approved and the manufacturing has to happen in that location. So we mention where the inspections were done. And TCB assignment number, as I said, to total all the reports will be traced through the assignment number 706 is the number. And since this is the first report, there is no previous report, and report number 1, and this is the date, and the item numbers are given 6-inch schedule 40 x 52 pipe. There's a different order we are talking about, and different material we are talking about here. Seamless bare pipe bevel, 12-meter random length. Each random double random length is nominal length is 12-meter long pipes. Longer the pipes are better it is for the buyers, because the field joints will reduce, which will give more productivity of the projects. And then suitable for our service, NACE MR0175, in line with the contract requirements. So now here, MPQT acceptable, and then ITP intervention points we are mentioning here. At the same time, we give a commentary whether those stages are satisfactorily done. And the person presenting the client, our inspector, citizen inspector on behalf of MACC, we are working for this project. This is 46th edition is the requirement for the pipe. API 5L 46th edition is the latest. Inspection test plan is the revision number 1 that we are using. Manufacturing specification we mentioned. So project specification number, all these. And all detailed inspections are documented here. And then we show some pictures of the test, and this is the mechanical test being done. And this is the Charpy impact test being done here. So impact value will be reflected here. There's a grain size detection and hardness 181 HV is the requirement, and we'll check whether it meets the requirement. And this is for the spectroanalyzer. You can see these are having the spots. They are put into a spectroanalyzer, and there'll be spark, and instantly readings will come here that will give you the chemical composition that's reflected directly produced by the machine, which is also calibrated to make sure the readings are accurate. And then here the inspector signs, here the reviewer, which was me in this case, and our stamp, and that goes to the customer. So this is inspection report number 2. So like that, we produce report for every visit. Imagine there were 21 visits done for this job, and 21 visits, 21st visits, a report is here. All these are done. The job is now complete. The status is changing. The job is complete and job is accepted. So all these requirements is clearly given. All inspection has been performed in accordance with, again, 46th edition. All inspection test plan requirements have been complied with. So you see 20% of ITP item number. This should be maybe SSC, HIC test, whatever is the number, step number 32 of ITP is complied with here. So this is the last, and this is how the pipes are coming. They're marking, they're strapped, and they're separators used to make sure there is no rubbing and there is no damage. Ends are protected with end protection caps. And these red bands are normally given by the customer specification that, okay, easy for identification for a grade and size, and these are strapped. So these 1, 2, 3, 4, 5, 6, 7 pipes will be strapped together, and they'll be handled and shipped. Again, this is inspected on 11th December. The report was made, and this was reviewed by an authorized reviewer, and company stamp is there. This report goes to the customer. Once all inspections have been done, as you have seen here, the status changed to complete. Otherwise, this will be striken off to show incomplete. Now, in this particular case, this is the last inspection. They did 11th December. The items are completed. result satisfactory. So we will issue now a release note. So IRN will be issued inspection release note. In inspection release note is a document that you have released the material. So this is the total quantity required. Total quantity released. This is the description of the material. HYST was the manufacturer from this date to this date. We did the inspection, and Nikuman is the person who did the inspection. Li Leong is the person, and also Nikoman is our inspector. He has signed and stamped the document, which is the release note, which is also signed by the customer requirement Aplos. On behalf of QC in this particular project, so their inspector also signed, and this is signed by Hangyang Valent Steel Tube, and they so it's the manufacturer seal, our seal, everybody has signed, and this material has now been released. So this much quantity will come. So what declaration we are giving? So assignment number is there. So with this, you can trace all reports, all inspection has been performed, ITP is updated, and the quantity ordered is this, quantity released is this is the description of the material. Now we are saying at the request of who requested us, MECC, because they are the one who's going to pay us. The undersigned surveyors of the organization did visit the facility, of Hangyang Valent Steel Tube from 23rd October 24 to 11th December 24 for inspection and random verification as per the ITP. The results of inspection, testing and verification and review of the manufacturer's relevant documentation, which is the MRB, and the certificates as per the scope of inspection gave no reason for objections, and the items are found to conform with the customer specified requirement to the best judgment of the attending survey. And that's the declaration we are giving from our China office. The order was secured from Kuwait office. That's how the whole process works. And when we complete the job, we update the ITP that everything is performed, and they will produce the signed documents. Here, basically, you can see the material, HIC test reports, SSC test reports, all those documents they're producing and sending to us. First lot shipment, first lot ship packing. So first lot MTC, you will find MTCs, material test certificate. So it is reviewed by our inspector and reviewed by the client representative. Now you will find there is a certification, they call it according to EN 10204 3.2. Now this 3.2 is a very important requirement. 3.2 means during the manufacturing stage, the independent inspection company witnessed the entire production and inspection in accordance with the requirement. And there is a separate quality control department and who are independent of the manufacturing responsibility. There was an independent inspection verification department independently sampled the material. They are not responsible for production. They're completely separate from the production department and their responsibility. So there is no conflict of interest. So independent inspection department has performed the inspection of those pipes within Hangyang Valley, and they will be signing here. For example, the inspection department inspection certificate is signed here by the inspection department responsible person, quality manager in this particular case. Then this was inspected by TCB on behalf of the buyer and on behalf of the end user, which is QC in this case, was done by Aplos Veloci in this case. So this is how we are issuing the MTC. And MTC typically contains all the chemical, mechanical properties. So carbon, manganese, silicon, sulfur, phosphorus, those requirements you have seen are all here with the maximum and minimum. And we have to check whether for different lots, they all fall within this acceptable range or not. And I did mention in one place that there will be a carbon equivalent. So you have to check carbon equivalent, and this meets within the specified limit of specified by the customer. NDT is okay, eddy current testing was not done, MPI was done full body. Tests, NDT tests, pipe body and pipe end testing was done, and you will find all the chemical composition is meeting the requirement. Heat analysis, product analysis was done and signed by all the parties. And here, this is the mechanical requirements. So now, if you, this is the impact requirement here. Now, this is mechanical properties. In the mechanical properties, we are giving tensile stress. This is the minimum and this is the maximum requirement. Enlarge it slightly. The requirement for mechanical property is here minimum is a 460 MPa and maximum 760. And this is the observed value 620, 640, which is within this range. Yield strength. Yield strength is supposed to be minimum 360 and maximum 530. That will come from the particular grade given in API 5L standard for this particular grade. And then you see the yield point is found to be within limit. Elongation minimum 22%, and we found here 31, 30, 29, 29.5 and 30%. So all these requirements are fulfilled. Hardness test requirements at the middle of the thickness, outside the thickness and inside the thickness, that show throughout the thickness at every location hardness is acceptable, because there's a thickness of the pipe outside is exposed to the ambient temperature, ambient air, so the cooling will be faster from the surface and also inside. But the central part which will conduct the heat, there is no radiation, the cooling rate of the inner core will be slower because the heat is conducted, and cooling is happening from the surface inside and outside. So arguably the cooling rate will be more at the surface inside and outside. They're exposed to the air, but at the center or middle of the thickness, it is slower. So slower means the hardness will be lesser, which is a desired property. So now let us see what is the value. So outside is 238 HV is the requirement, weaker hardness. Now this 238, 238 everywhere. Now these are the values, 178, this is maximum, right? Now what we found is 184, 178, 182. These are the different locations they have done inside the surface. And at the center, they found 182. There is not much of difference. And on the outside, 172, 185. Some variations are possible because the measurements being taken and the machine accuracies, etc. Some amount of variations are always likely. So now this is how hardness is reported. These are the Charpy impact value. Now just see 21, one value can go, which an average is 27. 27 joule is required minimum. Now what we found, one value can be minimum 16 and average value is 21 for this particular material. Sometimes it is given 27, minimum required 21 could be one value. Now what we found is these are the three values and averages this, and none of them and fallen below 16. So all the results are okay. So how we check Charpy value is always individual value and one value should meet minimum requirement. And there's also temperature, so this was done at minus 13 degrees centigrade. So because the lesser the temperature, the impact value can reduce, the material becomes more brittle, they become more fragile. So you may experience impact value may drop down. So in other words, with a smaller impact, this can break. It becomes like glass, for example. To drive home the concept, they become more fragile. So with lesser impact, this can break. So that's what the test is done for, to test their impact, ability to absorb impact. So this is how the whole reports are produced and it is signed by all the parties. And once this is done, we then issue the release note. That's how the whole inspections are controlled right from the beginning till the end. So, as I summarized once again, first of all, we must look at the customer requirement, the PO, ITP requirement for extent of our inspection, manufacturing procedure specification to make sure the procedure is validated and meets the requirement, and all subsequent production happens in accordance with the approved manufacturing specification, and then inspections are done throughout the production stage in accordance with ITP. Where we have to review, we have to review. Where we have to do witness, we have to do witness. Where it is hold, we'll have to physically be present or ensure that these stages have been cleared by us. And then when review is done, it means document review is done. Sometimes monitoring means you have to move around and see at random time, random sampling. You keep moving. There is no extent of checks given, but you are moving around and checking and monitoring everything is going on fine. And then when it is witness means you have to go physically present and then check the tests and then release the material. Before you release, look at the MRB, look at the individual tests, and all have been reflected, all have been reported correctly in the MTC, and it is signed by the manufacturer, signed by our inspectors, and as well as the customer when it is applicable. And then we hand over the inspection reports and the release note to our client and release note to the supplier. Now, one thing I have not mentioned, imagine there is a non-conformity. Some requirements have not been fulfilled. So in that case, we raise something called non-conformity report. So if there is a non-conformity, non-fulfillment of a requirement, we identify what went wrong. For example, a test failed or some defects were produced, some damage, some pipes were damaged, some pipes had lesser than required thickness. Whatever could be the deviation, we will mention those things in non-conformity report. As a third party, we are not authorized to accept any deviation. I repeat, as a third party, we are not authorized to accept any deviation. It is the prerogative of the customer. They know what is acceptable to them, and we only do inspection based on the specified limit specified by the customer. So if there is a non-conformity, we'll report it clearly, get an agreement from the manufacturer that they agree and there was a deviation. It will go through a systematic process of problem solving, and this is how ISO comes here. ISO 9008.7 talks about control of non-conforming output. So in case of a non-conformity, then they will have to identify what actions are needed. If it is possible to repair, they will have to repair. If it is to be downgraded, it may be downgraded. Normally, typical thickness reduced beyond certain level may not be acceptable. It can be downgraded for alternate application. Will certainly not accept any material which is in deviation to the requirement unless they're accepted by the customer. For example, the customer might need some material for crash barriers. There are some facilities you have to protect. Here, slight deviation to the thickness is not very important. They can say, okay, I can use those pipes for crash barrier pipes, but crash barrier pipes will be at a lesser cost. So the customer will buy this material probably if they fail, if there's a requirement, at a lesser cost. So these are actually degraded or regraded material due to non-conformity. They cannot be sold as original material for their intended purpose. That's how control of non-conforming outputs are managed. So as an inspection company, we make sure that the inspector is competent for the job and he is approved and authorized for representing us. And he is the person who is doing the inspection and reporting. And we will check his competence, qualification, whatever is needed for doing the job satisfactorily to our satisfaction, meeting the customer requirement. Sometimes customer might require to review their CVs. So we propose the inspectors and their CVs, and they review with the certifications. The customer accepts them or comments them accordingly. We engage the inspectors, and throughout the job, we monitor their performance in terms of reporting accuracy. So we monitor their performance and ensure that wherever there is a need for further training, are identified from those things, and that's part of competence and awareness, clause number 7.2 of ISO 9001 2015 standard. So we can actually integrate inspection business with ISO standard requirement. And then, of course, we ensure that all requirements are done in accordance with ITP has been done, authorized person has released the material, and all reports are retained for a specific period of time, typically say 5 years or 3 years. So we are accredited. When our accreditation body comes, they will check all those things, whether we have a process to identify the requirements, have we reviewed the requirements, have we communicated the requirements to the inspectors, and the inspectors were approved based on their competence, and they were assigned with a specific task, and they are the people who were involved in inspection, released the material in clause number 8.6 of ISO 9001 2015, and also and then we have provided all the reports to the customer in accordance with the requirement which comes from communication and requirement of customer, clause number 8.2. 8.2 is the customer requirement with regard to the products and services. So what we are supposed to give, including need for communication, coordination with the customer, and finally we take customer feedback, how happy they are, because we are in the business of offering a service that the customer feels confident that the right material is coming. That's the confidence, is the service that we want to give by doing inspection. So if they're happy, our business grows. So putting back into ISO, our service is third party inspection for this job. Customer is happy, and that's the reason for MECC is one of our most respected client, and we are doing job for last 15, 16 years continuously for them, and we are one of the most preferred service provider. Well, this is how the whole process for inspections are done. I hope you got a good understanding of what is required, and this is for you as a learner and for our inspectors as well. Thank you so much for your time.